One. Welcome to a Betatalk, which is a podcast I run all about renewable technology and low carbon. Today, we're going to talk about batteries. And, I'm just going to switch my gallery view. How do I get it? There we go. Today, we're going to talk about batteries. Did you know that you could turn your house into its own little mini power station? I know nothing about batteries, but I've got three people here who are experts. I'm going to introduce you to Jen. Now, Jen is the electrochemical storage lead for SPECIFIC, which is the Sustainable Product Engineering Centre for Innovative Functional Industrial Coatings. And you've been in academia a while, Jen, but you came from, I think you worked for Rolls-Royce. You've got an interest in titanium. I think that's where your expertise lies.
Yes.
I've got Gavin. Gavin's got more letters. Now, Gavin and I have never met, but we've got a very, very good mutual friend, Brandon, up in Wales. And Gavin's probably got about 35 letters after his name. So I'm going to say, if you go to gavin.wales, you'll see his resume. You are a Faraday Institution Research Fellow. Have I got that right, Gavin?
Yeah, that's correct.
He's very technical. He's got very technical honesty. He's got this virtual background, and you can see that he's affiliated with Birmingham University, I presume, is it?
Yeah, that's correct.
Now, Mark and I, we have met each other. Mark and I interviewed Mark at the Excel Centre, ironically, about 2 weeks before it got turned into Nightingale. Because Mark's company, you're the founder and MD, manufacture a lot of the batteries for the medical equipment, but if some of this medical equipment goes down. You've also been very active in producing PPE for COVID, and I think your university, Jen, has been very active. That you sort of swapped from solar, and they've been producing hand sanitizer. Have I got that right?
Yeah, we've set up to produce hand sanitizer and also 3D printed face shields and masks. So yeah, there's a lot of people sort of suddenly changing what they're doing, and we've got sort of large pilot line facility, which was actually quite suitable for that, in collaboration with some companies that we work with as well. So,
brilliant,
yeah,
brilliant. Well, I've just been sitting at home, just make sure I don't go out. So I want to talk about first. So we're talking about batteries today and battery storage. Now, I think one of the things listeners will want to know is, are batteries, and I want to bring you on this, Jen, are batteries sustainable? I mean, do we exploit resources anywhere in the world? Do we exploit people? Is it a sustainable technology?
Yeah, and that's a very big question. And I think the key is everything exploits resources, and everything that you do and any time you use energy will exploit people and resources. The key point is that we make sure that we're exploiting those people in a fair way, and that they're getting paid fairly for their work and in healthy environments that they're working in, and that the materials that we're using in a way that we're not wasting them. And so batteries can be made sustainable, and the sort of batteries that we are talking about here are what we call secondary batteries, I think mainly, which is batteries that can be recharged. And so that already is more sustainable than batteries that we first used, which was batteries that single use and then they get thrown away. So we're talking about lithium-ion batteries, lead acid batteries, also a good example of being recharged. And these batteries, the new technology batteries, so particularly lithium-ion, they are getting more sustainable. So we're still learning, there's still new technologies, and we're learning to exploit the materials in a more sustainable way and use less energy in making them. And that's often a big criticism that people have. Oh, it uses so much energy to make the battery that you might as well have burnt petrol. Now, that really isn't true, but we might want to expand on that further as we talk.
So, Gavin, coming to you now, you've authored quite a few books. You speak around the world. You've been on news shows around the world. Now, your expertise is this sustainability as well. Am I right in thinking about that?
Yeah, in broad terms, yeah.
And have we sussed that? Have we got that right? I mean, our batteries, if the world starts to use loads more batteries, have we got problems with sustainability?
So one of the things that we've been focusing on in our ReLib project funded by the Faraday Institution is the reuse and recycling of lithium-ion batteries. And so we anticipate this big shift to electromobility. More and more electric vehicles on the road will be a good thing. It will reduce carbon emissions, it will reduce local air pollution as well. But we've got a challenge when those vehicles reach the end of their life. And we think there's a great opportunity. In the first instance, we need to know about how to remanufacture electric vehicle batteries. So if there's a small problem, we can tweak them, make them good and put them back on the road. But then at the sort of end of the vehicle's life, when that battery's reached a point at which its capacity is decreased to the point where it's no longer useful in an electric vehicle, we might want to look at second life applications for that battery. So we might want to take that battery out of a car and put it into a battery energy storage system, because you know, for a car with a relatively low range, if that range decreases, it has a really big impact on how the user perceives the sort of performance and the usability of that vehicle. But if the battery is sat in a shed outside a building as a battery energy storage system, its total capacity isn't really such an issue in the same way. But then, of course, once the battery's enjoyed that second life, at some point at the end of the road, we're going to need to recycle lithium-ion batteries. So we've been looking at the right process for doing that, because batteries use strategic elements and critical materials in their manufacture that are in short supply. And we really need to think carefully about how to recover those materials and use them to manufacture new batteries.
I'm going to bring Mark in a bit, but one thing I forgot to tell you all prior to this: if you've got earphones that you can grab and near to you, because I think when I record these, it stops echo. But I know I've got some on. I don't know if anyone else has got them on. Only if you've got them near to you, because you probably have to run away and grab them. Mark, we've chatted earlier about how homes can become their own little sort of kind of power stations. They've got batteries inside. And you don't necessarily, because I know for a fact I've got friends who will think you need solar panels for this, but you don't, do you?
No, I mean, if you think of batteries that we all use, you know, cordless drills, cordless appliances that are around the home, you just put it in the charger to charge it up. So, you know, that could happen, say, with homes. You know, you can charge at economy 7, you know, 5.5p, and then use your batteries when it's 17, 20p per kilowatt. And so, you know, if you've got houses that are really east facing, they've got no sun on them, you could even put battery storage potentially to you know, off-peak charging, and then discharging at a higher price. I mean, discharging when the price is higher. But you've also got the opportunity of selling back to the grid. You know, when we all come home at 5 o'clock, cup of tea, shower, ovens come on because we're kicking gas out of homes. You know, our energy demand and the peak demands are really going to be quite challenging. So yeah, obviously the batteries can be charged via the mains and then discharged at peak time. So yeah, but obviously, you know, renewable is the way forward, capturing the wind and sun. So, you know, let's get them into the batteries and let's use what's above us, and yeah, generate what are called solar panels, because they're really just big battery chargers if you're not at home.
And this is something we're developing in specific and actually showcasing buildings which generate, store and release their own energy. And so this is key to have different battery technologies in them. And one thing that's key with these demonstrator buildings is that we showcase different technologies, because people often are nervous about buying something that's less proven, or they think, well, if I'm only buying this to save me money and I know it's got to last me so many years before I make money out of it, they want that reassurance, which is quite understandable. So on site at Swansea University, we have 2 buildings which generate more energy than they use. And they have 2 different battery technologies that we're showcasing. So in the larger building, we've got, I think it's 110 kilowatt hours of lithium-ion batteries. And again, we're doing something similar to what Mark is suggesting. So we store not only the solar that we're generating on site, but we also, particularly in the winter, take from the grid at night time. And then the university has a particularly high tariff after 5 o'clock. And so at that time we discharge to the grid. And also part of our research is looking at what's the most cost effective and what's the most carbon effective times to do that, and what tariffs generate the best behavior in people as well, because it's, you know, you can want people to do the best thing for the national grid, but they need to be incentivized to do that. People won't just do it because they want to. And you also need a control system that's simple. Although we have a lot of engineers who love turning the control systems up, down and round about, actually most of us don't want to have to think about that. If we buy a battery that we feel will be an investment to ourselves, and maybe a protection against power cuts as well, and I think that's quite an important thing, the robustness that it can give you. You don't want to have to be having to go in to do a PhD in battery control in order to get your money's worth out of it. You want to plug it in fit. So the control system and understanding what you need to tell that control system to do is really critical.
Yeah.
I was going to say there's really interesting work at Swansea, and your active office as well is a really interesting space. And I think another thing that's, again, it's a demonstrator that's based at Swansea, is it a salt battery you've got in the active office?
Yes, so I wonder, so this is in the active classroom, so our first building that we built back now in 2006, sorry, 16, not quite that long ago. So we did showcase a saltwater battery, which had a really good, it had cradle to grave certification, is very sustainable in the materials that it would use, very easily recyclable. Unfortunately, that's not had the lifetime we would have hoped. I don't think it's something that's wrong with the technology. I think it's more the implementation of the technology. And so I think we're taking that battery apart and trying to understand if we can refurbish it and understand why it didn't work and how it can be made to work. So the company who manufactured that went into administration, and you do get this a lot at the beginning of a new technology stage. Actually, sometimes the companies that did the real work and really made these things happen aren't the ones who actually will be around to deliver the success. So that's certainly a technology that I think has got potential but isn't there yet for consumers to buy. Another sort of technology that is there for Australian consumers to buy, so I don't know how widely this podcast gets viewed, Nathan, but is flow cell batteries, which instead of having an anode and a cathode where you just charge and discharge and the volume of charge is set by the size of the battery, you have tanks of electrolyte that you charge and discharge. And this flow cell battery that in fact was about to be installed the day before lockdown. It was a bit of a disappointment we couldn't get it in because it would be being tested now. It is 110 kilowatt hours again of a zinc bromide based flow cell battery. It's the first in the UK installed, we believe. So we will be testing that and understanding the lifetime and also the efficiency. So the efficiency for a battery is if you put 1 kilowatt hour of energy in, how much do you get back out to use? Now with lithium ion batteries, that's in the high 90s, so it's not really anything to worry about. With the flow cell batteries, that can be lower. And what we want to understand is, does how we operate it change the efficiency? So that is the research that we'll be doing on this to understand how we can get the best efficiency out of it. And we think this has got potential for stationary storage. So that's quite an exciting development that is first on the jobs list when we're allowed back on site.
Well, Jenny, can I add on to that? Because we've just come off an Innovate UK product with sodium ion.
Yeah,
now,
okay, yeah.
I really, really do like sodium ion. I think that has real legs when we're looking at the cycle life and the materials. So I think, being a battery guy since the 80s, and as you say, we've seen lots of products come in and never got over the line for whatever reason. But I do think sodium ion has real potential.
Well, that's music to my ears. And in fact, EPSLC agreed with you because they gave me a fellowship to study this technology. So the flow cell battery is sort of the large technology that's already available for people to buy. And that's one side of the research we do at Specific, which is, you know, to do the research of what you can buy now and how do we use it properly and the most effectively. The other side is sort of lower down the technology readiness levels, and my background is manufacturing, and I've been working in solid state solar, and I'm looking to use the techniques I used for manufacturing solid state solar cells, so not silicon but printed solid state perovskites they were actually, that we can then move to make solid state batteries in a similar manner. And I'm looking at, although I'm sort of fairly chemistry agnostic in the fact that I don't develop new chemistries, I'm not a chemist, but I use other people's chemistries and see how I can manufacture them differently. And certainly we are working with Professor Serena Margadona, who is the head of our Future Manufacturing Research Institute in Swansea, along with other collaborators on sodium ion batteries, and also looking at solid state sodium ion. But yeah, I agree with you. I think they've got good potential. And in India, where there's no lithium, and we've got collaborators in India, in Pune, so not only in the university, but there's a company, KPIT, who are looking to use sodium batteries in India. So again, what's the right answer for one country or one place is necessarily the answer for everybody.
Can I just, so for the layperson, when we talk about lithium and sodium, and obviously these things are on the periodic table, so lithium and sodium are metals, I suppose they're on that metal column. Now, and I suppose one's further apart on the electromotive series. Now, have I got this right? The further things are apart, the more electricity is generated, is that right?
Well, to sort of put it simplistically and without too much chemistry, which, as I say, I'm as a metallurgist originally, that's where I like to stay. But so you've got lithium, the lithium atoms are very small, one of the smallest atoms, and very reactive. Sodium is slightly larger but behaves in a very similar manner to lithium. And so in terms of the chemistries, broadly for a layperson, the chemistries are very similar. We're substituting sodium for the lithium. And that's why they're called sodium ion, even though there may be loads of other things in there as well. The same as with the lithium, where you might have cobalt or manganese. So they're different sodium types of cathode. The sodium's slightly larger, and the theoretical energy density is not necessarily as high compared to lithium. And so that's one advantage to lithium in transport. But when you're looking at fixed storage applications, actually the energy density is much less important, because, you know, it's just a box sat there. The cost, the sustainability and the lifetime are much more important to you than, you know, a slight increase in mass. That's the reason to move with sodium. One of the difficulties with sodium ion batteries, and is an area that I'm working on, is that the anode side, which I always have to think this round, which one's the anode and cathode, because the carbon is in the opposite place to solar cells. We have a carbon cathode in the solar cells and a carbon anode in the batteries. So, and in fact, Gavin and his team have got a beautiful outreach Jenga game that you can play that explains how the atoms from one side move across the battery. And I don't know, is that on your Twitter or linked up somewhere, Gavin? But
so yeah, the person that developed that is Elizabeth Driscoll, who you can find on Twitter, and she would be a fantastic interviewee for a future podcast, because she could get her Jenga and explain that to you.
I think we both follow each other. So that's a game that's, I mean, when you talk about a game, is that for sort of the younger generations, so anyone can have a go and learn about this?
It's used as a tool to communicate lithium-ion batteries, and I won't steal Lizzie's thunder, but if you imagine the game of Jenga where you pull blocks in and out of a tower, it's a little bit like the structure of a lithium-ion battery. Lithium intercalates and deintercalates. You charge and discharge the battery, and the challenge is obviously if you play Jenga, if you pull the blocks out too quickly, the pile collapses, and it's a little bit of an analogue for how batteries degrade, overcharge and discharge cycles. But just returning to an earlier point and something that I wanted to pick up on, obviously we're the Birmingham Centre for Strategic Elements and Critical Materials, and one of the things that we've been working on is a policy commission report chaired by Sir John Beddington, who was once the government's chief scientific advisor. And we've been looking at the UK strategy around strategic elements and critical materials. So if you think about a lithium-ion battery, the lithium's obviously, one of the components, but there are different chemistries, and some of those chemistries contain things like cobalt. Now, cobalt is really problematic because at the moment, most cobalt in the world comes from the Democratic Republic of Congo. Conditions it's sourced in aren't maybe, what we'd like to see. And also you see things like artisanal mining, and in some cases you've got sort of children involved in the supply chain, which obviously isn't acceptable. So we're concerned about the sort of resources that we're using, and obviously if we can transition to less critical materials where there is a broader base in terms of that supply chain, then we'd be able to make the UK much more resilient as an economy. And obviously with sodium-ion batteries, potentially different chemistries use different materials that are less critical, more abundant. And that's obviously a good thing for our industry if we can make those things work.
Mark, I want to bring you in. Are homes and building developers thinking about battery storage yet? Because obviously you would know that.
Yeah, I mean, that's one of my frustrations, is really to sit down with a house developer and start, putting where the inverter and the battery are going to be together, and put, the access into the home where it's not miles away and cabling lose efficiency. So it's one of my ambitions is to sit with some of these builders and just start to design the home because it's going to come, and design it for where the battery's going to sit and where the inverter's going to sit next to the fuse board. So it really is one of my ambitions, as I say, to get somebody who actually draws the plans up to build homes to actually start thinking about EV charging points at the front of the home, and obviously battery storage, and where the inverter's going to sit. It's not rocket science, but with a bit of a tweak in the home, we put them under stairs. We've got double case batteries. We're pretty comfortable with that, Gavin, to be honest with you. And we go through the testing, and we've gone through the big players over at BMZ in Germany. So the safety side is pretty paramount, but it needs to be very near the inverter. So, but we're seeing batteries put in lofts, and the wiring, the temperature up in there, the amount of stuff that's going on, it's frightening, because we're a battery company. Over 30 odd years, people have just been slinging lithium ions into the back of the vans, not thinking anything of it. And when they catches fire, and it certainly wakes people up. And that's what's happening with this technology. It's now coming to the consumer a little bit more on, I'll stick the batteries here, I'll put it in the kitchen, I'll put it upstairs in the loft, and how can you maintain it? How can you look after it? So all these things need to be thought of, when developing homes and making it, utility rooms possibly.
I just want to
where to store it.
So you mentioned fire there. Now I know that Gavin, I think you live in Wales, and obviously Jen, you're based in Wales, and I know Welsh house developers incorporate fire extinguisher systems, sprinkler systems. Now, first question, is there a potential for fire risk if people have these in their homes, and would it be a class D fire, because obviously lithium's a metal, or would it be a class E fire because electrical? I mean, what would people put a fire out with this kind of technology? Is that something that gets considered? I mean, do they catch fire?
Oh yeah, absolutely. I mean, some of the stuff that you see out there, And that's why your BMS, the circuitry, the cell balancing, all the stuff that goes into a battery pack, you know, whether you're Dyson building a cordless telephone or you've got a golf trolley, you know, it really is your battery management system, and having the thermistors and the cell balancing and the safety features is, because as I say, we're a battery company. And what worries me with the energy storage market, everyone is just sticking willy-nilly products in without really understanding, actually, this potentially could catch fire. And that's why, as I say, with the energy storage we do, are double encased, that it can hold on for 3 hours. Should it ever go, it's never gone on fire. Over 200,000 products that have been made, but should one go on fire, it is double cased and it has to hold it for 3 hours. So it's really, really important that, you know, we're starting to put fuel into homes, and these products need to be safe. And I do see some products on the market, and I do look at the safety protection, and it does worry me. And that's where I think other technologies have a little bit of a lead on lithium. But lithium is produced at fast scale, and the cost per kilowatt is obviously being driven down. So it is a great technology, not the safest technology, but if it is handled properly and it's got the right circuitry in, you know, that's pretty much an important part when you're selling products.
I think we can also, I think the government needs to learn from the heat pump, although there was maybe not a safety issue with the heat pump scenarios, where a lot of heat pumps, the technologies, there's no problem with the technology in itself, but there were a lot of opportunist installations that were not right for, you know, the situation. And I think at the moment batteries aren't particularly incentivized, but if that does start to happen, you have more danger as well, I think, of the installations that are, you know, put in because of some grant, as opposed to put in because that's the right, safe and beneficial thing to do. And I think that's got to be key
How do we mitigate that?
Well, we're working with MCS to write the new battery standard, because I say we sell batteries day in, day out, and seeing how people just handle these products, wrong chargers. You know, we talk about house fires. Most house fires are caused by kids' bedrooms leaving the mobile phone being charged. So not the batteries catching fire, but the houses are catching fire due to cheap chargers, leaving them on. And speak to firemen, most fires come out of mobile phones being left on all the time. So it really is. But MCS really have grasped this and brought out a new battery standard, because we're one of the guys helping write that standard, because, as I say, the market needs education around this.
I'm going to talk about, so my expertise really is training and mainly how we learn. So I am a bit worried. So I do tell my industry, it's all very well writing standards that are very up to date, but it's then how you deliver that so that the person coming away from the training, it's embedded in the knowledge, and that's what we're getting wrong. So I'm sort of privy to some of the standards being written at the moment. Brilliant. But it's then how we deliver. So I had a meeting a few weeks, well, actually a day after I met you, Mark, up in Manchester, because very, very, very large company. They use MCS engineers, but they said there's a massive variation between the quality of work that they can do. So they've all done the qualification, but a massive, massive variation. And that's a problem. It doesn't matter how good your standards are, it's the delivery of training. If we're going to get that right, I mean, I inculcate this all the time, but people in our industry or sort of higher echelons have got to learn about learning psychology. It's not just about how good you are with that technology. You've got to learn how people learn and implement that into your training. Because there's people walking out them training centres and they will completely forget stuff, which is a natural human thing to do. You know, it's studied back in the 18th century by Ebbinghaus. We forget stuff. And it doesn't matter how good your standard is, you've got to get the training right. And I do worry about that. And that's why we saw problems in the heat pump sector. That's why we saw problems in the solar thermal sector. We've got massive problems hanging boilers on the wall, for instance. People literally just do hang them on the wall. You know, Gavin and I have got a friend, Brandon, who's a fantastic engineer, you know, set things up properly, but that doesn't go on. And that's my biggest worry. That is my biggest worry with standards and training. You've got to get that training right.
Couldn't agree more, and I think that's where MCS see this, that we need training centres, and we're pushing that with colleges, construction centres, that it does need training. You're putting fuel into homes at the end of the day, and this does need proper training. You know, you don't leave 2 leads where you can short circuit, but they would, because they wouldn't think any different. So the training is very, very key to develop, delivering our energy storage needs that we need in the UK.
I mean, when you think about risk, we're used to consumers managing risk. You know, when you fill up your car with petrol and all the rest of it, you've got really energy dense hydrocarbon fuel, yet people manage to do that safely.
Yeah.
Incident, you've got bottles of LPG in some homes as sort of stores of energy, and you know, we've managed to get all of that right. But at the same time, I do think, you know, we're in the early stages. The market is only just starting to develop, and there's obviously some people that are, as you say, really scrupulous and high quality, and then obviously there will be people that join in Me Too and don't necessarily meet those same standards. I think one of the things for us is thinking about second life batteries and how can you validate those batteries in terms of sort of safety and performance, especially if they've been in a vehicle and you haven't necessarily seen the life cycle of that vehicle. Has the vehicle been involved in a collision or any sort of damage? Could there be any latent problems with the battery? And could that cause any challenges down the line? I think it's one of those things where you know, if you think about how the airline industry is managing risk around small lithium-ion batteries now, you know, obviously there have been some challenges both with people that have got onto planes with phones that have misfunctioned and also lithium-ion batteries installed in planes as well. But that's a very safety-critical industry that has managed to develop procedures and techniques for managing risk in that environment. And I think there's good lessons to learn there.
Yeah.
How the sort of airline industry has safety, you know, it's really paramount there. I think also in terms of the sort of risk to consumers, it's about awareness, and people won't necessarily focus on the instances where it's gone wrong. You know, with a new technology, we don't look at, for example, you know, vehicles that have crashed, internal combustion engine vehicles that have malfunctioned, you know, because we just accept things that happen as part of everyday life. There will necessarily be a focus on electric vehicles, things that have gone wrong, battery fires and all the rest of it, and people exceptions rather than the rule. So I think in those early days of the industry, it's really essential that we're on point with safety. We get it right so that there aren't a growth of you know, stories that could cause reputational damage.
I think that's a good point. I'm just looking at the time here. So we've got, I think I only get 40 minutes. I think we're going to make this a part 2. So I'll get all my guests together again. Because one of the things I wanted to talk about is this fact that the homes can become their own little sort of power stations where you're storing electricity cheap, and then you can then sell that back to the grid. Obviously, you can use it for yourself. And I think that's something I'd like to talk about the next time we all come on. Hopefully, we'll all be back to work the next time we all come on. I don't know how long the lockdown goes on for. Mark, you're obviously still out there working, obviously, because you're supplying.
Yeah, we're doing medical packs. So you know, we're doing various bits and pieces for applications that are really needed on the front line. So yeah, we've got a skeleton staff, and yeah, we're obviously assembling packs because, you know, they're in need at the moment. So yeah.
Well, I'd like to thank all my guests. Yeah, so our time's nearly up, so we'll definitely do a part 2. We might even do lots of parts, because I think this is going to be a very, very interesting topic. As you know, as time goes on, people are going to want to know a lot more about battery technology, and I think it's good that they can watch things like this because, like we just said, there's going to be spurious companies maybe sort of starting up and companies that are just chucking this stuff in. So I think if there's a good resource that they can sort of come on and look at and learn a little bit from, that's going to help the consumer. So thank you very so much, Gavin. Thank you very much, Jen, and thank you very much, Mark, and thank you to my listener. You can find this podcast on YouTube, and you can also find it if you go to Betatalk on Buzzsprout, or it'll be on iTunes and all the others. And I've been told by a social media guru that I'm supposed to tell people to subscribe to the YouTube channel and hit the notification button to do that. So thank you ever so much to my guests. Thank you.
Okay,
Bye now.
guys.